Okay, so let me explain once again. When you come to the HoRamamoorthy algorithm, there are two phases. Okay, phase one. So before going to the phase one, we need to understand the three important person. What are the things? Number one, the controller or the global site. So he is the one who is going to maintain a wait for graph. The second one is the status table. So each and every site, they are going to have a status table. Okay, so what is the status table? I will give you in a few minutes. Okay, I will give you an example. You will understand that. So what exactly is happening? You can see here, there are two local sites one, local site two. So local site one, what he is doing right now, so he is going to request, okay, the global site is going to request for the status table from the local site. In response, so what the local site they are going to do, they will respond with the status table. They are going to respond with the status table. So after receiving the status table, the global site is going to draw the wait for graph. Okay, by drawing the wait for graph, they are going to identify whether there is a cyclic wait or not. So if there is a cyclic wait, then they are going to say it's going to be, the site is going to get involved in deadlock, so resource allocation is not possible. So this is phase one. What is phase two? Okay, after identifying, okay, there is a cyclic wait in phase one. What phase two is going to do? There are some nodes between the sites. They have some common property. What do you mean by that? Say, for example, P1 in site 1 and P4 in site 2, they are common. What I mean? P1 is requesting for resource 1, which is locked by P1. P4, on the other hand, he is requesting for P1 resource. Are you getting my point? So this is what is the connection between P1 in site 1, P4 in site 2. So we need to identify this common nodes, okay, basically based on the resource allocation. Okay, I mean the resource is locked and the same resource is requested by the other site, other node in the other site. So we need to identify this common node, and after identifying this, again the global site will be requesting for the what? The status table from the local site. Only the common nodes they will ask. So now the local site in response, they are going to give the status table back to the global site. Now what the global site is going to do? So again they are going to create a wait for graph, and if still there is a cycle, again there is a cyclic wait, nobody can help. So the resource allocation cannot happen for this particular site because 100% they are going to get into a deadlock situation. I hope you have understood. Okay, so let me move on to the next one. Okay, let me move on to the next one. So where we can see the example. Okay, so I'll show you one example so you will understand. So before going to the example, so there are certain points you need to understand. Okay, so what are the things you need to understand? Number one, there is a local site. Okay, let me use the okay, so there is a local site, so which takes care of the status table for that particular local site. Then there is a global controller who is responsible to maintain or to draw a wait for graph, okay, taking the status table information. Then there is a request for status table. So the global controller is the main person to draw the wait for graph, and he is the one who is going to request for the status table. So the local site, what we are going to do, the local sites respond back to the global site with their status table. Now check for the cycle. After that, they will check for the cycle, whether there is a cyclic wait or not. If there is no cycle, there is no deadlock. So that is the definition they will give. Then the sixth point, if you see cyclic detected, then 100% they are going to get into the deadlock. So till point number 6, it is called what? Phase 1. Okay, one phase. Then what is a two phase? The second phase in a HoRamamoorthy algorithm, again they request for the local site for the status table. How they are going to request? So now we are going to identify the common nodes, as I told you. Okay, P1 P4. P1 is locked R1. P4 is requesting for resource R1, which was locked by P1. So these are the commonality between this P1 as well as P4. So we are going to identify these nodes and we are going to request for the status table. So global state, is request again for the status table. In response, they will send back the status table and they check for the cycle. Okay, that is what we call the wait for graph. They are going to check for the wait for graph. They are going to draw the wait for graph, and it is going to be the common transaction. Okay, so based on the status table, whatever you have received. So then they are going to identify whether there is a deadlock or not. If there is a deadlock, then finished. Nothing can be done. There is no third phase. Is it clear? So only phase 1 and phase 2 in HoRamamoorthy. So there is no deadlock. Again, the resource can be given to that particular node which is requesting for the what you can say the critical section. I hope you have understood. So these are the steps you need to understand in the HoRamamoorthy algorithm. Okay. Let me come back to the next slide, so where you can see the example. Okay, say for example, I have what you can say there is a global site. Okay, so I'm sorry. This is the global site. Okay, this is the global controller. We say the global controller. You see the status table. Local site, I have P1, P2, P3, and site number 2, local site number 2, I have P4 and P5. Now, what is this? P1, R1 locked, R2 locked by P2, R3 locked by P3, R4 is locked by P4, R5 is locked by P5. So this is one. And P1, he is waiting for R4, P2 is waiting for R3, P3 is waiting for R4, P4 is waiting for R5, and P5 is waiting for R1. Okay, this is one example scenario I have taken. Now, global controller or global site is going to first is requesting for the global state information from both the sites, correct? So global controller is requesting for the status, okay, table. So what the status table in response? So the site, local site 1 and local site 2, they respond back to the global site with the status table. So once they receive the status table, you come here. So what is happening? Start with P1. So what is P1 is happening? So P1, you can see here, P1 R1, okay, P1 is requesting for, waiting for R4, which was locked by P4, okay. So first we have to identify the waiting state, okay, all the waiting state we need to do. So P1, P4, P1 is waiting for P4, okay, P1 is waiting for P4, that is nothing but R4, okay. What is the next condition? P2, okay, let me say P2. P2 is waiting for R3 and R3 is locked by P3. So P2 is waiting for P3. That is nothing but R3, which is locked by P3. Okay. Now, what is the P3? P3 is waiting for R4 and R4 is locked by P4. So P4 is waiting for P4. P3 is waiting for P3. That is nothing but R4, which was R4. Now come back to P4. P4 is waiting for R5. Okay, that is nothing but P5. R5 is locked by P5. So here P5. So here you can see he is waiting for that particular resource. Now P5 is waiting for R1. So that's why P5 is waiting for R1. So this you can see here, this entire section of this particular global state wait for graph, they are getting into a cyclic wait. So ultimately, this is going to be, drive to the deadlock situation. I hope you are following what I'm saying. Okay. So the status table will be given to the global site. The global site is going to draw, okay, the what you can say, the wait for graph. After drawing this wait for graph, they are going to check whether there is a cyclic wait. So if there is a cyclic wait, 100% this is going to be a deadlock. Okay. Now, in second phase, what they are going to do. So as I told you, there are two commonalities. You can see here, P1 is locked, R1 is locked by P1. So here, P5 is requesting for R1. He's waiting for R1. So there is a common relationship between P1 and P5. Okay, there is a common relations between P1 and P5. I hope you are following what I'm saying. Okay, because here R1 is locked by P1 and P5 is waiting for R1. So P5 is waiting for P1. You can see here. Always you have to draw the wait for graph. Okay, don't draw the diagram for locked one. You have to draw the diagram, wait for graph for waiting. So P5 and P1, there is a common node. Are you following what I'm saying? R1 is locked. He is waiting for R1. So P5 to R1, there is a directed graph. Now, what is the second situation? Now, the second one is going to be, do you see anything with the P2? P2, R2 locked, and R3 is waiting, and R3 is locked. So there is no commonality between these two guys. Are you following what I'm saying? Are you following what I'm saying? So R3 is waiting, P2 is waiting for R3, and P3, you can see here, the R is waiting for R4, and R3, there is no commonality between, because you cannot see within the site. Okay, you have to go to the further side. I'm sorry. Okay, you need not to see within the site. Okay, within the site, we don't want to do anything. So global site, the controller is, thinking about the between the sites, they are bringing together and they are drawing the wait for graph. So do you see any commonality between P2 and P4 and P5? Nothing is there. So P2 is ruled out. So he is not in the second phase. But if you see that P3 has R4, he is waiting for R4, but R4 is locked by P4. So P3 is waiting for P4. Are you following what I'm saying? P3 is waiting for P4, R4. That means P4. The next one is going to be P4, any relation between, then P5 you can see, P5 and P4, there is a relation. Okay, P5 and P4, there is a relation. What do you mean by that? P4 is waiting. Actually, we need not to consider the local site. Are you following what I'm saying? But in this case also, if you see that one, P2 R3 is waiting for R3 and R3 is locked by P3. Okay, so in this case, P2 also you can draw. Okay, so P2 also you can draw. I think you can do this exercise. Okay, you please do this exercise for phase 2. Okay, so you can draw this one. Even P2 can come into the picture because here we are taking P4 and P5. Correct? So P5, P4 is waiting. P4 is waiting for. Okay, so why we are bringing this one? So P1 is waiting for R4. So that is nothing but R4 is locked by P4. Okay, R4 is locked by P4. So there is a link between these two fellows. So then P4 is requesting for waiting for P5. What do you mean by that? P4 is waiting for R4. Okay, I'm sorry, R5, where R5 is locked by P5. So when you see this one, again, if you draw P2 also, the entire cycle is going to be in a, what you can say, it is going to go into a cyclic way. And this is exactly the knot, how it is, formed inside the network. Okay, so because of this, even if it is, first phase, after moving into the second phase, still you are able to get the cyclic weight 100%. This is going to be, driving towards the deadlock. So resource allocation need not to be done. Okay, so this is what the HoRamamoorthy algorithm is all about. Okay, this is all about how the HoRamamoorthy is going to work. Okay, so I hope you have understood. Do you have any questions further? I can explain to you. You have any questions? Anybody? Any clarifications? So for a minute, I think you can switch on your videos. So we'll take one photograph. Somebody can take a photograph and share with me. Hello. Thank you. Someone can take a photo. Have you got the point? The deadlock situation. So how you are going to handle deadlock situation in the on a centralized approach. So this is all about the centralized approach. Okay. This is all about the centralized approach. And tomorrow I'll be teaching you, I know how the distributed approach in a distributed network, how this is going to happen, and hierarchical approach is the last one. Okay. So who's going to take the photograph? Oh, someone can take a photo. Otherwise, I will do because my phone is connected here. So somebody can take and you can share with it. Rachel, why can't you take a photo?
Nikhil sir, Nikhil will take that.
He will take. Okay, Nikhil. Have taken. Thank you. Okay then. So if you have any questions, please write it down. And tomorrow class, I will be teaching you about the what you can say distributed approach. And the day after tomorrow, we will discuss about the hierarchical approach. Okay. So these are the two things. One is completely centralized. The second one is going to be the HoRamamoorthy. Okay. So these are the two algorithms we have for completely central or centralized approach. Okay. So where we are going to take one person is going to handle the entire distribution of the scenario. Okay. So thank you so much. See you tomorrow.